has the pipe threads on them. That's an awful lot of surfaces. If I just made straight-sided things that plug together, it would almost be instant. But there's filleted corners on everything, and I just brought up drawings of pipe fittings off of Yahoo image search, and drew them exactly like the real part. This same thing we do with our security grills. I don't know if I've ever really done a video on that. There's been a few of them in the walk-arounds out at the job site showing what they're doing. It's stuck at 80%. Not very nice. But the security grills are drawn over pictures, not artist renderings or people think a fish looks like that. They're drawn from things that divers took, pictures that divers took of fish, or pictures of fish swimming in an aquarium, but they're actual real fish. And that limits your choices. Because you have to have patterns and stuff on the side of the fish that'll give you lines to fill in the big shape, so it can be a security grill. It's going to sit there. It's going to run out of memory, so we're just going to turn it off or try to. This is the packing gland. It's it's not on your screen. Please. I think part of this is because the camera should be turned the other way for what I'm doing today. This is not showing it with the bolt holes through it. But this is the shape of it. And you can see all these close lines together down here. That's the actual threads. So this blue thing and this purple part in the top, I drew them up as two separate pieces because I was having trouble with perforating the holes here. I thought it was me, so I just made a random shape and punched a hole the same way I was punching in this, and it went right through it like it's supposed to. I've never had rhino bulk on poking holes through a flat surface like that. I don't know what I was doing wrong. But I forced it to do it by doing a command is, it's like the split command, throw away which pieces you want to throw away, save what's left, and that's like a trim operation. So I broke it into all the separate operations. I split the plug I made to knock the hole with, threw away the pieces that was left, and used the end curves from what was left, and lofted that between the two parts. It was slow, but it did it just fine. But you shouldn't have to do that because Rhino is a really powerful program. This one here has got the holes in it. Usually I highlight something so I can find it. Again, it needs to be rendered for it to make any sense. I did this a different way. I did get the holes in it one time, but I wasn't satisfied with this, so I just erased it and went at it again. The actual holes that I used on the parts. No, I can't find it. It's up here. No, it's not in that one. Oh crap! Wrong thing. Okay, you can see here these couple lines are sort of showing you there's a surface in there, and there's like one line around this and a horizontal line. Again, we're off of the one screen. There's like a line down here going across. Those are just to show you there's a surface there. The name of those things is tessellation lines. And the more dense you put them, the more accurate the drawing you're looking at is, but not the part. If you're making a CNC file to cut the part, or you're going to render it into a picture or a JPEG, it uses the actual numbers and generates it. It's not making a copy of the picture on the screen. So while what I did was I made these, the ones that actually worked, I made these things with 100 lines instead of 4, so they're really close together. And doing that kind of stuff eats memory and slows the computer down. And that's why it doesn't want to go any quicker. And plus, this computer was never designed to do what I'm doing with it. I got it because I could use X-Plane on it. This is another example of overdoing the drawing. I could disassemble to show you, but this lid is on an axle, and you can actually turn it, open and close it. The cap is threaded down into the top of the thing like the real thing. It's got it doesn't show in here, but there's a little purple flat seal that's on the cap. All that's drawn in the model. The whole thing was modeled to make sense. You could almost make parts from it. CNC, you could make parts from it. I use a CNC called Mesh Cam. Let me see what this note is. It says, note these pipes are actually the same length with the check valve set clocked out of phase. That way the down pipes for this could be really close to this rod, and this one could be sitting right beside it. These pipes here could be shorter. There's things you can do to make it physically more compact. If you had a really small well or something like that, you might do that, but I don't see any problem with it having room to put a pipe wrench on this collar here, this thing that retains the union. You might want to swing a wrench around that to take that apart to get it out of the well. Anyway, this the whole goal of this thing is to make a pump, and this is a simple version. Let me get it into. I need to do better on my setup. So the piston runs up and down, sucks water through one check valve, piston gets to the other end, you go the other direction, check valve checks it from going out, it forces it up the pipe out of the well. And you can draw water 27 feet up to where this vacuum part of the chamber would be. And then from there up, it's however deep your well is. And you haven't got to worry so much about the weight of the water. If say that your well is 50 or 60 feet deep, and you wanted to push water up that high, the sleeve around this operating rods, this rod goes clear to the top of the well. That's where your pump handle hooks onto this at the top. The water the pressure of water is according to the depth. So this pipe and the other pipe, the water comes out of the top of the well is the same height. So the pressure on one side of the piston and the other side of the piston, the pressure is the same, because there's no bearing or seal in the end of the cylinder. 2 reasons. This threaded coupling up here fitting inside of the pipe going up. The pipe going up could be reduced down to 1 1/4 inches because you're not pushing water through it. All you're trying to get is hydrostatic head. But until that thing hits the side of the pipe, that's all that the pistons can be rocked in the bore. That's as crooked as you can make the piston is by the crookedness you can get into the rod. You know how much it can lean. And you notice that these pistons are 6 inches apart, 6 inches from here to there, and that keeps this thing from rocking in the bore. The 2 millimeter clearance here and the 2 millimeter clearance on this one down here, that's all this thing can move before that thing starts pressing against the cylinder wall. So you don't need a guide bushing. And we don't want a guide bushing because we want the water to freely come and go out of the top of this thing. Up here going up the well. This is the water will just go up and down inside that pipe, but it's establishing the same pressure head against this side of the working part as you're getting on this side from the water that's you're trying to push out of the well. They got the same depth. So that makes this thing sort of float just free. It's not hard at all, other than when it changes direction, of course, you have to overcome the kinetic energy to change the direction. This video got to be too long, so if you're watching this part, you're watching the second half, because I'm going to find a way to cut it in half. And you will probably learn everything you need to know about it and the concept of it from the first one. But thanks for somebody hanging in watching the second one. If you started with the second one, no need to watch the first half. It's this is just a little bit more explanation on what it's all about. If you learned anything from this, and I learned something by drawing it, by putting it together, how many parts it has and what it would look like, so I learned something. If you learned about how a gravity type water pump works and why it can't be 50 feet above the water level, because you can only pull it up 27 feet. We're cheating that by putting the pump down at the bottom of the well. So it thinks it's only pulling it up 2 feet or 3 feet, whatever the water depth is below it. And if the water in the bottom part of the well was over top of the pump, then it would come in all by itself. You wouldn't need anything. Anyway, so we're going to have two 24-minute videos out of this or thereabouts. If you learned something, give us a thumbs up. If you hate it, thumbs down, or just don't come back. I don't care. I have like 11 subscribers, and we're just giving you some variety during lockdown. I'm going to do next is a slideshow from putting the plumbing chases into the house forward. That's what the pipes actually sit in. The pipes are not poured into the concrete. They're into PVC chases. So I can snatch out any pipe in the place that when I feel like it and change it. If they leak, you know which one's leaking because it's going to run out of the end of the chase, one end or the other. Okay. So you have a nice day. Bye.